Time for some mathematics news. Today we're going to look at cumulative frequency, and cumulative frequency is a concept that we need to discuss first, and then we can use that to draw a really interesting graph that helps us to find the interquartile range and draw box plots. First of all, let's have a look at an example. This will help you to understand what cumulative frequency is. Here, there's some data on the amounts of pocket money that different students get, different 14-year-olds. So some of them get less money, some of them get more money. And what we've got here is the frequency, and the frequency is how many people there are in each category. So there are 26 people who get between $0 and $2. That's quite straightforward. The cumulative frequency gathers together all of the frequency as we go down the table. So the first number we're looking for is how many people got less than $2. Well, that's all 26 of those people. But the next cumulative frequency gathers together everybody from 0 to 4. So it includes the 26 people and the following 28. So 26 plus 28 is going to be 54 people. And then we gather together everybody in the next category between 0 and 6. So that would be the 26 plus the 28 plus the 11, which is going to give us 65 people in total. So the cumulative frequency gathers together all of the different frequencies as you go down the table. This number at the end, the 120 people, represents everybody that's in the entire table, and it represents everybody who gets between 0 and $12 pocket money. If I was to draw this as a graph, we can use cumulative frequency to draw an S-shaped graph, and these S-shaped graphs enable us to find the median and the interquartile range really quickly. So what I'm going to do is I'm going to plot these points. The cumulative frequency goes on the vertical axis, and the data you're talking about, the actual this is continuous data, is going to go along the horizontal axis. And we plot these points at the end of each category. So the first one goes at 2,26, which is about here, and then 4,54, which is about here-ish. Oh no, a bit higher up, there we go. Then 665, 876, 106, which is all the way up here somewhere, and then the last one is 1,220, right at the top. More like that. And so the cumulative frequency graph takes the numbers from the cumulative frequency and it plots them with the numbers at the end of the category. So the 2, the 4, 6, 8, 10 and 12. So the first one is 2 from the end, 26. And this number here represents all the people who get $2 or less dollars. This number here, this point here, represents all the people who get $4 or less dollars, including the people who get less than 2 as well. And it goes steadily up the graph. Once you've got the graph there in front of you, you can find the median from the graph. You can estimate it. The median is halfway through the data. Here there was 120 people. So halfway through the data would be the 60th person. I can go to 60 on the vertical axis, go across to the new graph, and then read the number off the horizontal axis, which would be, in this case, 5. So that represents the average pocket money for this group of people, going from 60 across to the graph and then down again. And that 60 is halfway through the data. There's 120 people, halfway through is 60 people. This is a different example. This time we're looking at a set of data where a teacher has timed people to answer a question. And there were certain people who got the question after a certain amount of time. So the frequency is just how many people are in each category again. There was one person who was super fast, between 0 and 1 second. There was most people were in the sort of middle group, and there was 2 people who took more time, between 9 and 10 seconds. We can find a cumulative frequency graph from this, but first we always have to actually calculate the cumulative frequency. So this will be 1 for the first category, 4 for the next category. I'm gathering together the 1 and the 3. This next one would be 12 plus 3 plus 1, which would be 16. Then I'm going to end up with all the numbers gathering together and we'll get the total, which is 108 altogether. That's going to be 1 plus 3 plus 12 all the way down to 2, all added together. If I want to turn this into a graph, I'm going to use the cumulative frequency on the vertical axis again, and the numbers at the end of the category to go along the horizontal axis. So the first point is going to be 1, 1, about here, and then 2, 4, 2 from the end of this category, and 4 here, so a little bit higher up, 3, 16, so we can then join these points together to form the cumulative frequency graph. Here I've got the graph that represents the cumulative frequency for the time taken for this question, and I can find the median value. In this case, it's not up to 120, the graph only goes up to 108. So there are 108 people. The median will be halfway through that data, which will be halfway up from 0 to 108, which is 54. So in order to find the median, I go halfway up the graph, not halfway up the scale, halfway up the graph, which is approximately 5, I would say. Brilliant. And that means that on average these people took 5 seconds to answer this question. If I want to work out the lower quartile, I have to go a quarter of the way into the data. This is like halfway between 0 and the median. So that would be halfway between 0 and 54 is 27. So 27 is about here. That looks to me as though it's about 3.8, roughly. Oh, actually 3.7. And I can find the upper quartile in a similar way. The upper quartile will be 3/4 of the way into the data. So that would be 54 is halfway up. 54 plus 27 is going to be 81. So 81 is here. And then that looks like 6.5, 6.6. Let's try 6.5. Not bad. Okay, it was 6.6. And the interquartile range is going to be the difference between the upper quartile, which was 6.6, and the lower quartile, which I've completely forgotten. It's going to show me. So it's between 6.6 and 3.7. So the upper quartile was up here, the lower quartile was here, the median is halfway in between, but the difference between them tells me exactly the interquartile range, the difference between them. And we could use that to compare this data with another set of data. Lastly, it's worth noting that the box plots that we were talking about previously can be quickly drawn once you already have these statistics. Whoops. You can find the lower quartile, the median, and the upper quartile, and then just move those lines down a bit and form a box for the lower quartile, the median, and the upper quartile, as well as the maximum and the minimum values, and then you can just draw a quick box underneath them. And you can use the same scale that we are using for the cumulative frequency graph. So a cumulative frequency graph can help you find the upper quartile, the median, the lower quartile, and draw a box plot. Good luck with the work. Bye.